Okay, we've heard about aeronautics at NASA. We've heard about low Earth orbit activities. We've heard what our plans are for beyond low Earth orbit. Are we still not optimistic or more optimistic than when you came in this morning? Are we still not having fun? If not, you might listen to the administrator's word this morning that said if you can't cut it, maybe you should think about another career. So, because we still have more to come, but wait, there's more. Now we're going to hear about space science and all the great things that are being done in the Space Science Mission Directorate. We're going to hear from another Goddard alumni member, that's Dr. Charles Gay, who's now the Deputy Associate Administrator of Science Mission Directorate, but you from Goddard might have known him when he was the Deputy Director for the Office of System Safety and Mission Assurance. He's also been a deputy within the Helios Physics Division down at headquarters, and beyond his NASA work, he spent 20 years in industry, so he knows that side of the house as well, where he worked with Lytton, Martin Marietta, Lockheed Martin, and Fairchild. He's worked on the TDRS program, Magellan, Topex, Terra, EO1, and he's from another local connection is from the University of Maryland. So please welcome Chuck Gay.
Thank you, Alan. After hearing that this list of jobs, it makes me wonder.
Yeah, I have the same problem.
Yeah, hard to hold down a job, I guess.
No, but we choose to check the next challenge.
Yeah. Well, what I'm going to talk about today is the incredibly busy and exciting year for NASA Science that we have coming up, and probably alternatively, I should have called this "Why I Love My Job," because it is really, truly incredible when you see the things that we have going on this year. I'll go ahead to the next slide. And we'll start 2 weeks ago, because that's when, after a nearly 6.5-year journey covering almost 5 billion miles, the Messenger spacecraft arrived at Mercury and was successfully inserted into orbit. First time a spacecraft has ever orbited Mercury, and we're going to proceed with a 1-year mission to study the composition and structure of that planet in unprecedented resolution. The next chart is the first image that we've gotten back from Messenger while it's in orbit around the planet. We've seen previous images from 2 previous flybys, but we're in orbit. We're going to have a lot more images this afternoon at a media telecon, 2 o'clock. And the large crater in the upper portion there with the rayed structure is the Debussy crater, which we've seen before. And although I don't know, maybe it's because I'm at an angle, but the bottom half of this picture, the southern part of the planet, is an area that's never been seen before, certainly not by a spacecraft at this resolution. And one of the really cool things that I enjoy about my job is that whenever, and it never fails, no matter what mission it is, when we get data back from, especially the first data we get back from a science mission, I'm always amazed when you sit down with the scientists and watch them as they see the data come in for the first time, and inevitably they say, I don't understand that. I mean, what's going on? I didn't expect that. And we end up generating more questions than we answer, and that's really a good feedback loop we get, because that helps us. It informs the future. You know, it drives the questions that then go into the formulation of new missions. So a lot more messenger imagery and spectroscopy to come. Let's go on to the next chart. Another encounter coming up in just a few months. The solar electric powered Dawn spacecraft is going to arrive at the Vesta asteroid in the asteroid belt in July. Vesta is the second largest object in the asteroid belt. It's about 530 kilometers in diameter, and we'll rendezvous with Vesta and orbit it for about a year, studying its composition and structure. And then depart for another rendezvous, this time with the largest object in the belt, Ceres, which is on the order of about 1,000 kilometers in diameter. And one of the really interesting things about this mission is that these are the two largest objects in the asteroid belt, but they're vastly different. Vesta is very rocky and dry, resembling more, looks very similar to an inner planet, while Ceres is dusty and kind of clay-like, and it more resembles an icy moon. So, vast contrast between the two asteroids, and this will help us understand the evolution of the solar system, how bodies are formed, and so on. So that's coming up in July, and then we have 3 planetary launches coming up starting with the next chart. We're going to start with Juno, which is a mission to Jupiter, and a lot of firsts will be demonstrated by this mission. Juno is the first solar-powered spacecraft to go to Jupiter, and it's been enabled by a very unique mission profile and orbit around Jupiter. But we've got 3 very large solar array wings. At Jupiter, will generate about 400 watts. And more than half of that's going to be required for heaters and thermal control. So that'll leave, I think, about 150 watts for the science investigation to study the origin and evolution of the gas giant planet. So that's the mission is going through final testing, and we'll be looking to launch at the opening of the launch window, because we've got 2 more following that we've got to make as well. Go to the next chart. Grail, these are twin spacecraft that are going to be launched in September. Grail is going to study the interior structure of the moon. It's very similar to the Grace mission that that studies the Earth structure, and we've derived incredible science data from Grace, and we're looking to do the same with Grail in the very near future. Next chart. Then we have MSL. This is one of the things that I guess I kind of took for granted for at least a little while, was the fact that MSL is really 3 spacecraft. We have a cruise stage, a descent stage, and a rover. All 3 have to be tested. All 3 have to be integrated and tested. All 3 have to work together precisely to execute this mission. But ultimately, when we arrive at Mars in, I think, August of 2012, we're going to land a 900-kilogram rover on the surface of Mars, and we'll determine whether Mars is or ever was habitable for microbial life. So that's going to be a big one this year. Okay, next chart. Earth science. We have the Aquarius mission. Aquarius is going to study sea surface salinity, and that's going to help us understand the nature of the oceans, the ocean's response to climate change. Aquarius is in fact being shipped right now from Brazil to Vandenberg Air Force Base for launch. Aquarius is a collaboration between NASA and the Argentine Space Agency, CONAI, and some facilities in Brazil were used to support test. Okay, next. I think we're really going to launch NPP this year. It's been a long time coming. In October. NPP is even more important today than when originally envisioned. In addition to its climate measurement suite of instruments, NPP is going to play a critical role in the nation's weather forecasting system. So we'll be anxious to get that one where it's safe and sound up in space. Okay, next. Then shortly or early next year, we have a heliophysics mission, which is also a pair of spacecraft, the radiation belt storm probes, launching in May. These 2 spacecraft are going to perform a comprehensive study of the Van Allen radiation belts and help to provide more insight into the geospace, the environment that the Earth that we live in Earth also have implications for the study of space weather. So who knows what we're going to learn from this mission. Okay, next. And Sophia, Sophia, the airborne observatory, is I guess not fully operational, but we are starting science flights. This is a bad image of the forecast instrument in the infrared. But we also, I think next week we're going to be flying the German instrument Great. So we will begin ramping up to full science operations, maybe as early as the end of this year. But we have to work in some aircraft enhancements and upgrades in the meantime. So we're all very anxious to getting Sophia operational and flying. Okay, next chart. And we continue to make really great technical progress on the James Webb Space Telescope. We have just finished the final polishing of 7 flight primary mirrors. They came out spectacularly. We will be seeing the delivery of at least, 12 of the flight mirrors completely through test this summer, with the last 6 coming later this year. So it's becoming a reality. The hardware is coming together for integration, and we're really excited about getting this phenomenal observatory put together and tested and launched on an Ariane rocket. So we've talked about the activities that are happening this year, and this doesn't even include the other missions that are in the queue, in development. In heliophysics, we have the MMS mission, we have the Solar Probe Plus mission, we have Earth Science missions, OCO2, SMAP, and ISAT. We have the Mars Aeronomy mission, MAVEN, that'll launch in 2013, and several Explorer missions, an Astrophysics NuSTAR Hard X-ray mission that launches actually early next year, I think February, and the Heliophysics IRIS mission. And there's more to come. We have, we'll be making selections for the Discovery program, New Frontiers program, and Explorer program throughout this year, through the summer. More solicitations upcoming for the Earth Venture class, small satellite mission or small missions, and we also, as you know, continue to have the ROSES, the Research and Analysis program, where we invest, nearly $750 million a year. Which are typically 3-year grants, so about a third of that is solicited each year. So that's ongoing. And then for the next chart, the future, our future direction is guided by the scientific priorities established by the National Academy of Sciences, and this has really served us collectively, all of us, well, because it's helped to make the science program a pretty sustainable and enduring program, throughout administration changes and changes in Congress. We've had actually the first ever Earth Science Decadal Survey released in 2007, and that survey has really formed the basis for the various tiers of missions that we have planned over the next 10 years in Earth Science. Astrophysics Decadal Survey was just released a few months ago, and that is the priorities reflected in that decadal formed the basis of the 2012 budget request. And we just received a few weeks ago the Planetary Science Decadal Survey. So we're now, chewing on that one and formulating our plan for it there. And we expect an update on the Heliophysics Decadal in sometime spring next year. So for the next 10 years, if you want to see what science holds at NASA, look at the decadal surveys. That maps our way forward and directs our mission sets and budgets. So I'll end there, and we can move on to the next speaker.
Thank you, you, Chuck. By the way, if you haven't seen the movie Hubble in 3D down at the IMAX theater, you ought to really run, not walk, to go see that. It is a fascinating presentation of galaxies and nebula. Plus, it has the crew from the last flight to refurbish the shuttle or refurbish the telescope at the Hubble telescope, and it's just amazing to see that. If you don't get excited after seeing that movie, you don't have a pulse. So go check that out. All right. So we've heard from the mission directorates that do the programs to implement what the president has asked us to do. And now we're going to hear from our newest associate administrator, Dr. Woodrow Whitlow, who joined us as an associate administrator in February of 2010. And he is now the missions, the AA for the Mission Support Directorate. And those of you will remember Woodrow from when he was out at Goddard as a center director, when he was down at Glenn, wrong G, Glenn, as a center director. He had been at Kennedy as a deputy director, so he knows NASA very well. He studied and got his PhD at MIT. And in his operation, he covers human capital, budget, system support, cross-agency business, institution, and contract support functions. So he has this very important function, and those of us in the mission support offices never quite get the credit we deserve compared to the mission directorates. But he's got a very important job to make sure that the mission directorates can actually implement all these things that they have planned. So please welcome Woodrow Whitlow.
Yeah, thanks, Alan. And I guess I could make this real quick and just say, what they just said. As Alan said, we provide the capabilities for the mission directorates to implement their missions. Now, Alan sent his email out and said, when you talk to the audience, tell them something that they don't know. And I know the Administrator Bowden's recognized Harriet Jenkins, and so I'm going to tell you something you don't know. It goes back to 1979 when I was finishing graduate school, and I get this call when the phone rings one morning. For you students, back then you had to get out to bed and walk to the kitchen and get the phone off the wall and answer it. So it was about 5:30 in the morning. And on a Monday morning, and I tell my wife, go answer the phone. And so we argue. So she walks out to the kitchen and she answers the phone and comes back. And she was excited because it was NASA. And it was Harriet Jenkins. And the first thing I said was, "Are you at work? It's 5:30 in the morning." And she says, "Well, we got an offer to you. Are you coming to work at NASA?" And I say, "Well, I'm thinking about it and I'll get back to you." So the next morning, phone rings at 5:30 in the morning. And I convinced my wife to go answer it, and she comes back, and it's Harriet Jenkins on the phone. And so this goes on, and finally about Friday, 5:30 in the morning, the phone rings. My wife says, "Go answer the phone." I said, "I don't know, it might be your mother." So she goes and answers the phone and comes back and said, "It's that lady from the moon. You better tell her something." So I said, "Dr. Jenkins, if I promise to come work at NASA, would you promise to stop calling me in the morning?" And so we have this mutual agreement. So all the stuff that I'm about to tell you, if you don't like it, you can blame it on Dr. Jenkins later on. I say, but I'm pleased to be here and just to tell you some things about the mission support area. And as Alan mentioned, it's a relatively new directorate. The administrator formed it announced it last February. I actually showed up April 5th of 2010, and so I had the invitation to come and be part of this panel last year. And I think the only reason, and I didn't make it, and the only reason Jim Kirkpatrick invited me back was I'm on the board of directors, and he only gets his dues when he sees me in person. So he asked me to come back, and so I'm happy to be here. But the reason that the administrator formed this directorate was he was looking to bring additional senior management focus to all the issues that we have surrounding the institution and how we support the mission directors and provide the capabilities to the agency to do what we do. And so things are pretty spread out, and so he as part of the reorg that he announced in February, he created the Mission Support Directorate. And when he announced the creation of the directorate, he was looking around and he was saying, well, I want somebody who's been around the agency, who knows the agency, and preferably someone who has been a center director. So I started calling all the retired center directors that I knew and told them there was this opportunity coming up, and you might get a call from the administrator. And so when he asked me to do this job, I told him, well, I've been at Kennedy and I commuted from Cleveland to Kennedy. I don't think my wife's really gonna support this. And so this is the same. So he said, I want to talk to her. And this is the same wife when she was visiting me at Kennedy. She came down and we were having the 35th anniversary celebration of the Apollo-Soyuz test project, and this Friday night dinner. And she said she wanted, and John Travolta was the speaker, and she wanted to go to the dinner. I said, no, I'm going to spend Friday night and the weekend with you. We're not going to the dinner. But she insisted. So I said, well, when you come in, bring me a suit and a shirt, a tie, and some shoes, and we'll go on over to the Davis Center for the dinner. So she was on her way. I'm in the elevator. I get stuck in the elevator. So I called her up and said, I'm stuck in the elevator. And she says, well, I'm going to see John Travolta. I'm going to leave your clothes in the lobby, and if you get out of the elevator, if nobody takes your clothes, try to find a way on over to the dinner. So Charlie talked to her, and lo and behold, here I am. But so what we do is in mission support is that we enable the program and institutional capabilities so that we can do our aeronautics and space missions. And I like to define capabilities as a combination of three things. Most important is people. Second, facilities and laboratories. And then third, dollars, so we can actually do some things. And so we've heard from Tom Irvine about wind tunnels, airborne facilities such as airplanes to do say icing research, for example. We have thermal vacuum chambers to test spacecraft, and we have the necessary infrastructure to launch things. And so this directorate enables the things that we do. And so what we're doing is that one of the big things that we're doing is we're identifying and sustaining a diverse workforce, a workforce that represents this country and takes advantage of all the resources, people-wise, that this nation has to keep us in a leadership position in the aerospace arena. And we ensure that all the vital assets that we need are ready and able to support on demand. And so we're doing some very exciting things with the workforce right now, because we are in this this massive transition phase as we go from shuttle constellation to the programs that we're implementing now. And so we have these transition issues of how do we get the workforce that we have from where we are now to what we're going to need to do to implement the exciting missions that you heard my four colleagues talk about earlier. And so some of that's going to require retraining some people. It's going to require some rebalancing of the workforce that we have, and to make sure that when we get to a steady state, if you can imagine that, that we have the skills and capabilities that are necessary. And we also have to make sure that now I got to be politically correct here, that we have people of broad ranges of experiences, and we have a continuum people who can lead the agency as the more mature and more experienced workforce rolls out and they continue to fill in behind us. So we have some very exciting programs, like mid-level leadership programs. So we have people of not very high grade levels yet, learning all the things they need to do to be the Chuck Gays and the Laurie Leshins and Bill Gerstenmaiers and Tom Irvines and you and Alan Ladwigs of the future. And we have our first program, and you'll hear from some of our students and from the students this afternoon, talking about their developed program and even our student programs that we have to build the pipeline to bring the workforce in. And so the mission support budget, consists of two phases. One is the CAS budget that you probably may have heard about, which is a nice target for reduction on the Hill, and that, among other things, supports the centers. And I know people like Rob Strain like to call me Dr. No, but he doesn't remember the 99 things that I approved for him, only the one that I have to tell him that we have to defer for later consideration. And also in construction and environmental compliance and restoration budgets. And so those numbers are about a little over $3 billion for cross-agency support and about $350 million annually for construction. Now, why is construction so important? And it's really exciting when you talk about construction and environmental compliance, because one of the things you may not know is over 80% of our facilities and infrastructure is over 40 years old. And we have the Apollo Air infrastructure and it's not aging, it is aged. And if you go to some of our older centers like Langley, which was established in 1917, or Glenn, you have buildings that are much older than that. And so the president has said, you have to be more environmental, more energy efficient, and so how do we get there? And so we have a plan where we're going to drive the age of our buildings, at least 63% of them will be under 40 years of age, and we'll do that over a 40-year plan, over a 40-year period. And so we'll do it by aggressively building new buildings, like the Propellants North building at Kennedy Space Center, which generates more energy than it uses, so it actually dumps power back onto the grid. And over the last 5 years, we've taken down 735 facilities and taken over $1.3 billion worth of infrastructure off the books, and so that's always a good thing. As we want to get similar capabilities but smaller. So with this 40-year period, we'll reduce our footprint by 15% while preserving and generating the capabilities that we have. And so it's an aggressive program, and it's exciting to see things start from basically from nothing, and then to come up with all these LEED silver, LEED platinum buildings, and the suite of facilities and capabilities that we're going to have as we move forward. And so how do we determine the capabilities, and how do we get to the capabilities that we're going to have? When I leave here, I'm going to go talk to our workforce planning people who are over at the Bolger Center, and for those who've been there, hopefully I'll get there in time to get some of the good food they serve, and that's the only reason I accepted the speaking invitation. But as part of the budget process, we have these capabilities forums where we work with the centers to determine what's the supply of capabilities, and that includes workforce and infrastructure, and the cost that it takes to maintain that, and then we work with the mission directorates and the centers to say, now what's the demand? And so based on the demand versus the supply, we determine the things we need, the things we don't need, and the things we don't know if we need them. And the things we know we need, that's a no-brainer. The things we keep them. The things we don't need for any foreseeable amount of time in the future, that's a no-brainer. We get rid of it. And there might be some things we don't need, but we need to keep them for strategic reasons. And I will make the decision to carry those along. And the things we don't know, we make a decision on what to do with them. And if I get it right, I'm a big hero. If I get it wrong, then my successor will get a chance to correct my mistakes. And so, to leave a little time for questions, I'll just stop there. And just one more thing that you don't know. I guess protective services falls under mission support, and I guess we're testing our emergency notification system. Today I got an email that says call this number. So when you saw me in my wallet, Alan, I wasn't getting $50 to pay for a Galaxy. I was finding my Gets card, and I found out my government phone doesn't work. So, so I reached in my pocket and pulled out my private phone, and I did make the necessary phone call. But we've got time for a few questions, and thanks again for being here.
Okay, you've just heard how NASA intends to spend the FY12 budget request. It represents 0.45% of the federal budget. Those of us that have been in the space business for a while will remember when the decimal point used to be moved over a notch. But we are doing an awful lot for 0.5% of the budget. And you all are part of this. You all are our partners, our collaborators. And, you know, we are the aerospace community that wants to find excellence and still defines excellence in this country. You know, 100 years from now, people are not going to remember Charlie Sheen or Ashton Kutcher or New Jersey Housewives or any of those other inane shows that seem to capture the public imagination now. They're going to remember the kinds of things that we're doing. So at this point, we'd like to see if you have any questions for our panel. And we've got some time left. And so have at it.
Is anyone at NASA looking into dark matter, the area where a large part of the universe's energy is said to exist? And can you tell us anything about it?
That sounds like a Chuck Gay question.
The astrophysics.
Yep.
How about now?
Give him that mic.
I'm looking.
There we go.
There we go. It's working now. Yes, in fact, the Astrophysics Decadal Survey identifies dark matter research mission. The W1 mission has aspects of that. It's currently awaiting the previous decadal survey's priority mission, JWST, to complete before that one can really start up in earnest. We're investing in technology development for that mission now, and it will be expected to ramp up later in the decade.
And for $75, I'll sell you some dark matter.
That's all right. I just have to add on that, of course, Hubble every day is working on dark energy, and the James Webb Space Telescope was specifically designed to be an incredible dark energy answering machine. And then W1 will follow on from there. And of course, we'll learn lots of new questions that can't be answered by Hubble or James Webb, which is why we need a W1.
And that's John Grunsfeld from the Hubble Space Institute. In the back?
So one of the challenges that the exploration folks have been going through with HEFT and HEF2 and HEAT and now HAT, is trying to get the exploration program within the budget box. And what everybody keeps asking for is innovation and new ways to do things. So my question is where is in all of the technology development the process technology that's going to allow us to find those new ways to do things other than 7120.5 A, B, C, and D, and finding new ways for government and industry to work together in newer and better ways?
That sounds like an excellent question for the Office of the Chief Engineer and the Chief Technologist panel this afternoon. But let me say, seriously, I think we certainly should invest separately in thinking about innovative process. But we need to create innovative process as a part of our programs, not apart from them, if you will. And so we have, in fact, one of the 4 teams that's doing pre-formulation work for the SLS is dedicated to thinking about innovative ways to infuse affordability and sustainability into any vehicle that we develop. Things like, how do we reform our oversight processes? How do we leverage our industrial base smartly and think about, targeted consolidations where they might make sense? All sorts of different approaches to thinking about doing things differently and smartly. New, different procurement tools. I mean, anything that we can think of, at least we're thinking about, we're considering. Things are on the table that probably wouldn't have been on the table before. So I assure you that we are doing our very best to go off and think about how we get the maximum leverage as we go forward to make sure that we can do these vehicles smartly and affordably. And Bill should probably chime in some on that one too if you want, because they're pioneering some of these things on station now even.
Yeah, we've done some things. The Sabatier system, which takes waste carbon dioxide and hydrogen and combines them to make water. We acquired that essentially as a service where the device is on orbit now, and as it generates water, we only pay for the water that was generated. We spent no development dollars in actually building that, and we let industry go ahead and pick their own standards, pick their own processes to put that together and interface it into the space station system. So I think that's one thing we're exploring, where we can do more of that, where the ownership and the rewards sit on the industry side, that they can spur some pretty innovative and creative things, and that's been pretty effective and works pretty well. We're looking for more areas. And as Laurie said, our challenge in exploration is to try to figure out how we can embed that into programs to begin with at the beginning, as she described, and we're actively doing that even in a formulation phase.
Yes, Steve? Oh, sorry, in the back there.
Sorry.
The debris environment in LEO represents a growing threat to our ability to do science and our investment in space.
Can you just talk loud? Just talk loud. Debris, orbital debris, I think was the question.
Okay, the debris environment in LEO represents a large threat to our ability to do science in space and our investments there, and also for the entire international community. What is NASA doing to create an active debris removal mission? And if we are doing something, will international cooperation be a part of that?
Okay, so the question is, what is NASA doing about the debris problem in low Earth orbit, and is it an international activity? Any of you can take a crack at that? Bill?
We don't have an active debris removal program that I know of. We've been thinking about that, but we do have some policy with respect to generation of debris. There's some new requirements in terms of second stage disposal, that we make sure that second stage spacecraft deorbit, so you don't have essentially a second stage that can then blow up or break up and create more of the debris environment. We also have requirements on pressure vessels, battery systems, etc., to try to minimize the amount of debris generation. So I would say through our launch policy, we're working pretty aggressively to make sure we don't increase the debris population by disposal of spacecraft. Even from space station and other things, we also have some disposal requirements of when we can dispose of hardware, and there's certain requirements of when they need to re-enter. So we're trying to minimize the generation, but we're still conceptually starting to think about what a debris removal program would be, and we're also trying to develop some better ways to actually monitor the debris field that's in orbit today.
Okay. Steve?
Oh, actually.
So they're.
Oh, I'm sorry. You got
the mic.
I didn't see you sitting. You got to stand. There you go. Next one, Steve.
This question, I guess, is for Charles Gay. You mentioned a lot of missions that are launching in the next year or so, and to my knowledge, that's the majority of the missions currently in progress. What can we expect as students to be the future goals in space science, and what kind of timeline can we see on proposal awarding and future missions, I guess?
Well, it's a continuum. We have two categories of missions. We have strategic missions, and we have PI-led competed missions, and both aspects of those continue. Certainly through the FY12 budget, and would expect it to continue beyond. In the PI-led missions, we have the Discovery mission line in planetary, predominantly New Frontiers program line in planetary, and the Explorers program line, which is shared by heliophysics and astrophysics. Those are both, actually all three of those PI-led mission lines have received strong endorsement from the National Academy of Sciences, and recommendations are to not only continue those, but to augment those to the degree possible. So we fully expect those to continue to be a pipeline for new PI investigations, focused investigations related to the key scientific questions that we're seeking to answer. And the strategic lines, form the basis of the activity that's necessary to satisfy or answer the questions posed by our decadal surveys, in all four primary disciplines. So, and we've got a $5 billion a year budget in science, and we can do a lot with that, and we expect to do a lot with that. So I would say that there is a good future there. We also have the RNA, the research activities. We have at any time over 3,000 investigators that we fund every year to do the developmental work for some of the new missions, but also to analyze the results of the data that's coming back from the current missions. So there's an awful lot there to choose from, I think.
Okay, thanks. Steve? And please identify yourself and your affiliation.
Steve Brody with ISU. When the subject of U.S. and China in space comes up, generally the buzz is competition, race, words like that. So I was very pleased to see on Bill Gerstenmaier's chart that under the 59 countries of utilization of the station, China was listed there. And I wonder if Bill or anybody else could elaborate on the cooperation and any prospects for the near or midterm future in cooperation between U.S. and China, both human and robotic.
Well, I'll start. There have been several bilateral meetings with China between science organizations, and right now the status of that is that we're exploring areas of potential collaboration and cooperation. But there seems to be it's going to take some time. I mean, there's a pretty significant time span between bilaterals. I think we're still trying to schedule the next one, but we've had those both in earth science and planetary science. And I think I'm not sure about heliophysics, but we'll continue to see how that pans out.
I would just add that the references there are for some very small scientific cooperation kind of things that we're doing. There's no big major plans for any kind of human spaceflight activity. It's really more of a policy decision that needs to be given to us before we can really take any next steps in that direction. So at this point, I would say there's really very little involvement with China directly, except for the things that Chuck talked about, and some very small things we're doing on station. But it's really a policy thing that we need to hear from the government what we should be doing in that area before we can proceed.
Yes, in the back.
Hi, Julia Bodnarik. I am a graduate student co-op at NASA Goddard Space Flight Center and a graduate student at Vanderbilt University. I had a question regarding the funding for technology that just came out from the chief technologist to help with new innovative ideas and concepts all the way up through maturing technology. Regarding that, what other efforts are being put in place to help instrumentation from the TR level, like 1, 2, or 3, to bridge that gap to get ready to actually go on a mission and be competitive for some of these new frontiers and other missions?
Chuck.
Well, there's a couple of aspects to that. And first of all, I'll say that the science area, as well as exploration and space operations, we're involved in working closely with the Office of Chief Technology to develop the roadmaps for to input or identify our needs, our long-term needs. So the technology roadmaps that have come out do reflect the overall needs of the agency. Independent of that, we do have technology development activities going on with the Science Mission Director, specifically for instruments, and that occurs primarily in the RNA lines, as well as Earth Science has a long-standing Earth Science Technology Office at Goddard that has been doing a fantastic job in identifying and formulating and doing that early technology work on instrument concepts that ultimately have kind of moved up the ranks to either airborne flights and in the areas of planetary and astrophysics and heliophysics. The RNA missions or RNA technology developments often end up on initially sounding rocket flights, and then we like to kind of keep a scorecard to see how many of those eventually wind up as instruments or contribute to the instrument developments on spacecraft. So there's a pretty good track record there for starting at those low levels and migrating those forward to ultimately a flight on a spacecraft.
Okay, other questions? Yep.
Hi, I'm Marcia Smith with SpacePolicyOnline.com. Dr. Holdren seemed to suggest that you might be looking at a reflight of Glory. Can you tell us any more about that and what the chances are?
Well, first, we're certainly not going to do a carbon copy reflight of Glory, and that's largely owing to the fact that the Glory bus was a repurposed bus to begin with and largely obsolete at this point. We'd have a tough time rebuilding that. But what we are doing right now is looking, we're at the early stages now. We're looking at the impact of the loss of the Glory measurements and looking at that in context with what we have flying now, what we will have flying in the near term, and to identify where the gaps are. And also in parallel, looking at what would be the kind of instrument that we would need to best fill that gap. Is it a reflight of the APS instrument? Is it a different instrument given the technology we have today? So that's being looked at as well. And then ultimately we'll look at the best way, if we decide that there is a gap that needs to be satisfied, we'll look at the best way for executing it. Is it a free flyer or is it an instrument we can put on another spacecraft and not to save the, to get some synergy between an upcoming mission that we already have planned for flight. That way we could, save some cost for, a separate spacecraft, a separate launch vehicle, which really adds up quickly. So we'll be doing that over the next several months and factor that into our budget development process.
Okay, I've been given the sign. One last question.
Hi, I'm Akash from the University of Illinois. I was wondering, one of the slides mentioned that the International Space Station would be supported until 2020. I was wondering what would be the future of this investment after 2020? What would be the role? Because it is a giant international collaboration project. So what happens to this after 2020? Thanks.
What happens to ISS after 2020?
Again, we've been kind of looking at this as this is the research phase of space station. So we spent a lot of time, as the charts alluded that I showed you, building this thing. Now the idea is over the next 10 years to actually really kick up the utilization and the research on board space station. So what happens beyond 2020 is a function of how successful that research activity occurs. We think we have enough structural life in this station to probably extend beyond 2020, maybe to 2028 or so, or possibly even further. But it's a function of how much return we get, how effective the research is, can we actually get a good return on investment. If we can do that, we'll continue to operate station internationally. The partners have been kind of going through. The U.S. started leading the effort. We're the first country that said we would go to 2020, followed quickly by the Russians. The Europeans just did that last month. They've committed to 2020. The Canadians are now off in the process of evaluating that, as well as the Japanese. They've been through the first stage of extending to 2020. So I think that's the first phase. So we'll see how the research goes. If it looks predominant, looks very good, very successful, we'll continue to operate the space station. And then ultimately, we will deorbit the space station at some point in the future, and we had to file an environmental impact statement with an actual plan to dispose of the station at the right time when it needs to be done. But that hopefully is a long way off if we can do our job and get creative and use it as an engineering and research test bed.
Okay, well, thank you all very much. You've been a very good audience. I want to recommend to the college students in the audience to use AAS as an opportunity to begin to build your networks and find mentors that will help you in your career. And just before you run out the door, Chris Brown, the name of the event at Goddard on May 14th is?
Explore at NASA Goddard.
Explore at NASA Goddard, May 14th, a big activity. I hope we'll see some of you there. And then coming up next is STS 134 on April 19th. Thank you all.